So I have to raise up my hand in front of God. Yeah, that's what. Okay, so so we're going to continue on with example number 4. Now the function here is already stated. It's a root of x. So this is the parent graph of this. So this says here, describe and sketch the graph of the transformation represented by this. So I'm just going to rewrite this for a second. Y minus 2 equals to negative root of, now can you see here, 3x plus 3? What are we going to do is we need to actually factor out a common factor of 3. So we have x plus 1. Okay, so we factor out a common factor of 3 to get that x plus 1. So looking at that, what are the transformation that happened there? Okay, let's take a look at the 2. Yeah, okay, so the 2, let's start with this one, because what does this mean? Up to. What does this mean? Vertical reflection over x-axis, right? So flip down. What else? What does the 3 represent? It's B. Yes, it's B. The B tells us the horizontal compression or stretching. But in this case, what would it be? Horizontal compression by a factor of 1/3. Okay, is everybody okay with that? So horizontal compression by a factor of 1/3, because if this is the B, the factor would be 1 over B. 1 over B. And then what happens here? Yeah. This one here is going to be negative minus negative 1. So that means it's translating it to the left 1. Left 1. Right? Good. So what do we have in here? I'm going to do the mapping. Okay. The mapping looks like this. X divided by B, or the same thing as timesing it by 1 over B. Okay. Plus H, horizontal shifting. And then A times Y plus a vertical shifting. Yeah.
That's straight.
Oh, this one? Oh, okay. So what we did was we had to factor out the 3. So 3 times x will give us 3x, and then 3 times 1 would be the 3. So we factor out the 3. Yeah. So let's not, yeah, make sure we put the 3 there. And there's a brackets. So we factor out the 3. So we got the B. Is that good? Yeah, if there's something in here that you're not sure of, yeah, let me know right away. So that's good now? So what's happening here? X over B. Well, what's the B? B is 3, so divided by 3, plus H. Well, H, because this is a horizontal shifting, H would be negative 1, right? So minus 1. Good? And then the Y would be A times Y. The A here would be negative 1. I'm going to make sure that everybody who's reading this gets that. So it's negative 1A for A. So negative 1Y plus k plus 2. Good. So once this is identified, I think it's a little bit easier to figure out what the points are, the corresponding points. So here, the points are 0, 0, 1, 1, 4, 2, and then that's it, right? Those are the key points. So far, so good? Yeah? Everyone's okay? 1, 1 is here, 0, 0, 1, 1, and then 4, 2. So let's do this one here. So go ahead and try it. I'll do the corresponding points as well. Is everybody okay with this? I got negative 1, 2, negative 2/3, 1. I'm going to end up with like some kind of a fraction here. That's not a big deal. So before we even graph this, we want it to be compressed by a factor of 3. So it's going to be mushed in this way, reflected down. So it's going to reflect down and shift down and left. Okay, all that stuff. Okay, so negative 1, 2. So negative 1, 2. Negative 2/3, negative 2/3, 1. Where did I get this? This one here? Yeah? Oh, okay. So this one, I'm going to grab this graph paper here. Yeah, I don't want to go deep into this and then not knowing what happened here. So are you okay with x divided by 3 minus 1? So the b is 3. So that's going to be x divided by b. So the b is 3 right there. And then to the left 1 unit. So it's because it's minus 1. So the left 1. So that's what it came up to be, right? Negative x divided by 3 minus 1. So the x here is 1. Okay, so we're going to put x over 3 minus 1. And then our x is 1, so I'm going to go 1. One third minus 1. Okay, so this one here, when you subtract fractions, you have to have the same denominator, right? So you're going to go 3/3. So this is going to be 1/3 minus 3/3. So that's going to be negative 2/3, negative 2/3. Okay. A little bit of fraction going on in here.
Is it okay if you change it to decimal?
Yeah, that's okay. That's okay. Yeah. Yeah, certainly you can do decimal. Okay, so where was I? Negative 2/3. So basically what I do is if it's in thirds, this is what I'm thinking about. 1/3, 2/3, 3/3. So negative 2/3 is here. 1. Okay. And then this is 1/3. So from 0 to 1, that's 1/3 is here. 1/3 is right there. 0. Then that's the point right there. So it's going to be something like this. So you got compressed quite a bit. So got compressed, shifted up, left. So that's where it ended up being. Okay, is that good? Any questions? Let's try this one. No, not necessarily. So what's going to happen is that if you take a look at this, that's a good question. Because last time we said when we take the square root of something, it ends up being to the top. Well, if everything's inside, so let's say the square root of, whatever's inside the radical sign, this one should be a positive value, right? Now, so after, whatever this is a positive value, but then there's a negative inside. So whatever the positive is multiplied by a negative value outside. So it's okay to be negative. But that's a good thing. Yeah, you're thinking about what we did before, right? Yeah. Okay, so example 5. Example 5 is pretty much the same thing. Root of x, describe the graph and sketch it. Okay, so here, what's happening in here? I can go like this, y minus negative 3. And then the 2 is already outside. That's great. And then for this one, what we could do is we can factor out a negative 1. So let's factor out a negative 1. So you got the x plus 4. Okay. So now this kind of describes every single transformation that happened here. Let's start with this negative 3. What does this mean? Down 3. So down 3. Okay. Down 3. So that means the k value is negative 3. Right? K value is negative 3. What does this mean? It's on the outside. This is the a value. A is 2. This is the vertical stretch by a factor of 2. Vertical stretch by a factor of 2. What does the negative 1 mean? Reflection where? Horizontal reflection. So there's really no compression or stretching horizontally, but there's a reflection horizontally. So there's a reflection. It's going to be horizontal. I just put horizontal reflection. And then what happens here? Oh, I forgot to put minus, but what's happening with the 4? Left 4. Okay. So this means here, maybe this would probably help a little bit. So down 3, that means the k is equals to negative 3. Vertical stretch by a factor of 2, that means the a is equals to 2. Horizontal reflection, that's going to be b is equals to 1, but it's negative 1. Is that okay? And then left 4, so that means this is the h equals to negative 4. So these are our A, B, H, and K. Okay, so what's the form again? X divided by B, because the factor is 1 over B, right? Whatever the B is, it's going to be the factor is 1 over B, so it's 1 over B times X plus H, horizontal, A times Y plus k. So that's a general transformation. Starting with xy key points. What's the transformation here? So x divided by, what's the b? -1, so -1 plus h plus -4, so -4, comma, a is 2 times y plus k is -3, so it's -3. Good. Again, our key points are 0, 0, 1, 1, 4, 2. Okay, so go ahead and figure out the corresponding points after all the transformations happen. Did you get something like that? -4, -3, -5, -1, -8, 1. Now the graph kind of looks like that. Where does the arrow go? Is it at the bottom or the top? It's a reflection or horizontal reflection. So this, what reflected there. So, yeah, so this is, yeah, very good. Awesome. Any questions? Okay, number 6. The graph of the function y equals to f of x. Okay, well, we don't know what the f of x is. Doesn't matter. But we know it's been transformed as described below. Write the equation of the image. Write the equation. So it says here, a horizontal compression by a factor of 1/5. Horizontal compression factor of 1/5. So which one would that be? So the horizontal compression of 1/5, that's affecting the b value. So if this is the factor of 1/5, that means the b is going to be 5 from that. Is that okay? So the factor is 1/5, so that means the b is 5. And the reflection on the x-axis. So that means instead of just the b being 5, it's going to be a -5. So now with reflection, with horizontal reflection, it's going to be would be -5. Yeah. Yeah. Okay, hold on. Reflection in the x-axis. Okay. I think we should go like this, the word over. Yeah. I'm
Well,
gonna
I feel
use the
like
word,
in would be this way, and then over would be that way.
you know what, I think at this particular, and in this particular booklet, in and over is the same. So here, reflection over the x-axis, that's gonna be a vertical, with vertical reflection. So, yeah, we gotta do a good job in using the proposition here, in, over. So over the x-axis, so over, if this is the x-axis, it's gonna be a vertical reflection. So it's gonna be A would be -1. And a translation of 4 units left. 4 left. Translation of 4 left. It's gonna be, the H is -4. Okay, so let's put it together. So Y, okay, there's no vertical translation, so just Y equals, A is -1. I'm gonna just put -1 there for now. F of 5 times X and then -4.
It's technically plus 4. It's technically plus 4, because you need to go to the right.
Right, +4. Very good, Cody. I didn't see any. X plus 4. Okay. Now it's going to be, this is your compression by a factor of 1/5. Translation, -4 to the left. Reflection over the x-axis. Let's take a look at the letter B. Vertical stretch. Vertical stretch by a factor of 4. So that tells us the A, what did I say 4? 6. Vertical stretch by a factor of 6. So A is 6. Reflection. I'm going to use the word over so we're consistent. Reflection over the y-axis, or in the y-axis, or over the y-axis. So that's going to be a horizontal reflection. So that's going to be a -1 for B. And a translation of 8 units down. So that means that's the K of -8. So let's put it together. So Y minus -8, so Y plus 8. Okay, A is 6. F of -X. That's it. Good. So far, so good. So left 8, vertical stretch of 6, and then reflection over the y-axis. So -X. Do letter C. Horizontal stretch by a factor of 3. Horizontal stretch by a factor of 3. So the factor is 3. Factor 3. So that means the B is 1/3. Perfect. Vertical compression by a factor of 1/3. Vertical compression, factor of 1/3. So that means A is 1/3, yes. And a translation of 0.5 right and 4.5 up. Okay, so you go 5 units to the right. So that means H is 0.5 and 4.5 up. So that's K is 4.5. Okay. So what's the equation? Y minus positive 4.5 equals 1/3 times F of 1/3 X minus 0.5 brackets. That's a final one.
And it's okay to put like a mix of decimals and fractions.
Yep, that's okay. This one I probably wouldn't go 0.33 or 0.3 because this is going to be a non-terminating decimal, right? This one is okay. Yeah, 0.5. If you want, we could also do 1/2 as well. That's okay. Good. How do you like it? Is it getting better? Yeah. So everyone's going to get 100%. Yes. I'll probably talk to you about the test next week when it's going to be. Okay. Example 7 is going to be a long one. Okay. So what I'm going to do is I'm not going to do this on this page because I'm going to run out of room. I'm going to do this on a separate page. If you want to do that on a separate page too, that's okay. Okay, let's see here. Okay. Now the challenge here is that here's the original graph. Determine the equation of g of x in the form of that, given the graph of y equals to f of x and the transform function g of x. So this is the original. It got transformed to something like this. Okay. Any suggestions what happened? Yeah, this one is very obvious. There's a reflection over the x-axis. So there's a vertical reflection going on. So good. There's going to be some kind of shifting vertically down.
Yeah. And a horizontal stretch.
And a horizontal stretch. Okay, horizontal stretch, that's a good one. How do we know it's horizontal stretch?
Because you can see the distance in the spread.
Yeah. Can you see here? Do you see? Very good observation. Yeah. So here, A to B is this much. Then it's after it's been transformed, now it's like this much. Got bigger. So there's a horizontal stretch. Reflection, yes. Do you think there's a vertical stretch? Do you think it's got? How do you know that? The points got spread out a bit. Okay, yeah. So here used to be like 1 unit up, like one between A and B, right? Used to be 1. And then it got stretched. So like, can you think of like a rubber band? It got stretched. So now they got vertically stretched. Good. So there's any horizontal translation. Did it move left and right? No? Okay. Okay, now, so we kind of see what's going on in there. So obviously there's going to be, just by looks of it, there's a horizontal stretch. So the B value is going to change. There's a vertical stretch, so A value is going to be changed. And then there's a reflection. So let's see. Here it goes. Very nice. So here's what we're going to do. Let's take a look at the f of x. And there's a g of x. Okay. Now, let's start with horizontal distance from A to B. Go like this. What's the horizontal distance from A to B? 1, okay? This one. Yeah. So if this is A, how far apart are they horizontally? Now, what about the horizontal distance from A prime to B prime? 4 times horizontally. So from here to here, it's 1, 2, 3, 4. Is that okay? Can you see 4? 1, 2. So this is B, this is A. Their horizontal distance from here to here is 4. 1, 2, 3, 4. Okay, so if that's the case, what do you think the factor is? What did we have to multiply the x by to get the 4? 4, right? So there's a factor of 4. There's a factor of 4. So therefore, B is equals to 1/4. That's 1. Now let's do vertical distance between A to B. So if A and B here, how far are they vertically? It's 1. And that's not bad, right? 1. What about from A prime to B prime? How far are they? 1, 2, 3, 4. 3, 4. Just their distance. Their distance, how far apart are they? Right? We're not saying from A to B and B to A. It's just basically 4. 4 for now. Okay. So what factor did we have to do that for? There's a factor of 4. Okay, this is the vertical distance, the vertical stretch. So that means A must be A should be just 4. Yeah. Okay. So we got the B and then the A. Now from here, we know it's been stretched in 2 different ways. And then what else? There is a reflection. There's also reflection. So that means, I gotta say this, reflection over the x axis. So that means A should be -4. Okay, so not 4, but it's gonna be -4. This is the one that we're gonna use. Okay, so what else? Now, if from here, we need to know now if there have been translation. Okay, what kind of translation do we have? So A is at 0, 0, right? Where is A prime?
Like,
0, -5. So here from 0 to 0, nothing is added or subtracted. So it's the same. But 0 and -5, yeah. So it's gonna be down 5, right? So 0, 0. Let's see another one. It works there. What about B? Four. So we said there's nothing horizontal, but then there is a horizontal there. Can't be different, right? Okay, so here's what we're gonna do. We're gonna take B, point B at 1, 1. Point B at 1, 1. And then what we're gonna do is we're going to vertically stretch by a factor of, well, -4. And horizontal stretch by a factor of 4. So where would that be? If you're at 1, 1, if B is at 1, 1, and it's vertically stretched by a -4, and horizontally stretched by 4, this 1, 1 has been moved to where? Okay, X horizontally stretched by a factor of 4, so this is going to be 4. And then the Y would be vertically stretched by a factor of -4, vertically stretched by 4, and then negative. So in this case, I'm going to go back in here. So this B, after it's been stretched horizontally and vertically and reflected, it should be at 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. So this is the B after stretching. Okay, that's the B after the stretching. Now the only thing that's going to be happening is the translation. Did it move left and right? No, it just went down by how much? By 5. 1, 2, 3, 4, 5. So in this case, so this is the B after it's been, so no horizontal translation, and then vertical translation 5 down. So let's put it together. Y minus 5 minus -5, so it's minus 5 equals A is -4, F of 1/4 x plus 0. We can go plus or minus 0. So put it together, clean it up. So y plus 5 equals a negative 4f of 1/4 x. And that's it. So we have to deal with how it was stretched first and compressed. And then from there, we do the translation last. Okay, let's do last one, letter B. It would be a little bit faster. What kind of transformation happened here? Horizontal stretch. How do you know? Is it horizontal stretch or shift? Oh, shift. Okay. Yeah. Okay. Good. How do you know? You probably thought, like, okay, it went there, right? Okay, good. Is there horizontal stretch?
Gotcha.
Horizontal stretch. Was there horizontal stretch? Look at the A and B horizontally. It's 1 unit. A and B, 1 unit, no horizontal stretch. Is there any vertical stretch?
Yep.
Vertically, A and B is 1, and then A prime and B prime is 2, right? So there's a vertical. I'll just do that here. Vertical stretch by a factor of 2, because it became twice as much distance between A and B vertically. Is that okay? Vertical stretch. Do you see that? Yeah. Okay.
Is there a vertical reflection?
Now, what else? It flipped over. So this is the original, and then it flipped over so that there's a stretching, but there's also a reflection. Vertical reflection. So that means the A is not just 2, it's going to be negative 2. A equals to negative 2. Got 1. Okay, what else? Let's see this. Let's just pick B as our point. So B is 1, 1. B is 1, 1. But we're going to vertically stretch by a factor of 2 and reflect it. Okay, so let's see here. Vertically stretch by a factor of 2 and reflect. So it's going to be, is the B going to be changing? There's no horizontal, right? So it's going to be 1, comma, negative 2. 1, comma, negative 2. So this is where the B is after stretch. So if this was the B after the stretch, and then the B prime was there, so how did that happen? It went left and up. So how many units did it go left? 1, 2, 3, 4, 5, 6, 7. Left 7. 1, 2, 3, 4, 5, 6, 7. Up 7. So left 7, up 7. Good, let's put it together. Y minus negative 7 A is -2. F of,
Can you repeat the left 7?
left 7, this one?
Yeah.
Okay. So from here,
Or eight is five,
Isn't it left 5?
or eight, five, or eight, seven.
okay, let's see, hold on. So 1, 1 is your B, is our B right there. There's a vertical reflection and stretch, so that's right here. Yeah, so this one is at, now this is where the B is after the stretching and reflection.
Mm-hmm.
So we're gonna go like from here, this is the B, basically it's gonna be like this. This is the B. This is not their final destination because the final destination is up here. So you go 1, 2, 3, 4, 5, 6, 7 to the left, left 7.
Is there not a horizontal reflection as well? Because if you were to
Mhm.
just vertically flip, the B and C would still be on the right side, but they're on the left.
Oh, good point. Because A and B, good point. I only focus on this one. You're right. Yeah, there's a C, horizontal. Okay, yeah, awesome. Thank you. Let's fix that. Thank you. Let's see that. Good point. Did anybody see that too? Well, I did.
I felt weird.
It feel. Yeah, no, good. There, because it is weird. Okay, let's see here. Let's get rid of this one. Okay, so this is the B. And the B is on the other side, yeah. Thank you. So there's a horizontal reflection, so that gives us, is -1. So down to -1. Oh, so now that's what you were saying about 5 units. 1, 2, 3, 4, 5. Yes. Good. Okay, so be after reflection and stretch. Okay, so this is the B after reflection and stretch. So that means the B is right here. So now we're just gonna go left 5, still up 7. Okay, thank you. Left 5, up 7, so -2F of -1 X minus, so this one should be up 7. Minus -5. So let's clean it up. Good. Much better. Yeah, I focus on A and B that I didn't recognize are on the opposite side. So let's clean it up. -2, f of -1, x plus 5, x plus 5. Good. Much better. Much better. Good job. So when you're correcting the teacher, that means you know your stuff. That's good. Awesome. I appreciate that. Okay, good. Okay, so that concludes that. Any questions? I knew this is gonna take longer. So I'm gonna pause this video now.